In this video, we are looking at comparing data. To compare two sets of data, we want to compare an average and a spread. So that can either be the mean and the standard deviation, or it can be the median and the interquartile range. The mean and standard deviation are best when there are no extreme values because they take all of the pieces of data into account. The median and the interquartile range are not affected by any extreme data. So in a case where there is extreme data, then the median and the interquartile range will be the best one to use. This first question, the summary statistics for the times taken by two groups to run a race are shown below. We need to calculate the mean and standard deviation and then compare the distributions. So the mean is all added up divided by how many? So for group A, we have the sum of the x's, so the total is 398. There are 20 people, so the mean is 398 divided by 20, which is 19.9. So that's the mean. The standard deviation squared is the mean of the squares minus the square of the mean. So that's 8,138 over 20 minus the square of the mean, 19.9 squared. So that is the variance. If we square root it, we get the standard deviation, which is 3.3. And then the same for group B. So we want 341 over 15 for the mean, which is 22.73 recurring. And then the standard deviation is the square root of the mean of the squares minus the square of the mean, 8,005 over 15 minus our 22.73 recurring squared. And we get 4.11. So now we can compare the two data sets. So we're going to compare the mean and we're going to compare the standard deviation. So the mean is 19.9 for group A, 22.7 for group B. So the mean time taken in group B is greater. And then we're going to compare the spread. So the standard deviation is lower. So the spread is lower for group A. So the spread of times is lower for group A. And then one question for you to try. See if you can give it a go. So again, we've got two groups and we need to calculate the mean and standard deviation. So for group A, the mean is them all added up divided by how many? So 836 over 20, which is 41.8. The standard deviation is the square root of the mean of the squares minus the square of the mean. So the square root of 35,564 over 20 minus the 41.8 squared. So we've got 5.56. 5.56. Exactly the same thing for group B. So the mean is them all added up divided by how many? That's 555 over 15. So 37. And the standard deviation, the square root of the mean of the squares minus the square of the mean. And we get 4.65. So now we need to compare. So compare the means for the two groups. So the mean time is greater for group A. 41.8 is bigger than 37. So the mean time taken for group A is greater. And then we'll compare the spread. We've got 4.65 and 5.56. So the spread is lower for group B. The spread of times is lower for group B. Here's another question. This time we've got box plots. So we've got the box plots showing the heights of two groups of plants. Compare the distributions. So again, we're going to compare an average, which is the median this time, and the spread, which is the interquartile range. So we can look at them and we can see the median is greater for group B. So the median height is greater for group B. So we've compared the average. Now we compare the spread with the interquartile range. The interquartile range, which is the spread, is lower for group B. One question for you to try. Give it a go. So we're comparing the average, which is the median, and the spread, which is the interquartile range. We can see the median height is lower for group B. Could have said it's higher for group A. And the spread is greater for group B. The spread, which is the interquartile range, is greater for group B. And again, I could have said group A is less spread.